Hi, my name is Sarah Hartley, and this is my demonstration video for my Advanced Physical Computing honours project. I'll start by briefly touching upon the inspiration behind Allergy Safe, which is the name that I've given my honours project, the background research that I've done, and why my device is able to compete with similar products on the market. I have a lot of personal experience in shopping for someone with severe life-threatening allergies, so I know how frustrating and time-consuming shopping can become, especially during this pandemic when the priority is to shop safely and quickly. Allergies are becoming increasingly common, and while children are most commonly born with them, they can also develop at any stage in your life. The European Academy of Allergy and Clinical Immunology estimate that by 2025, over half of the entire population of Europe will have at least one food allergy. I noticed a gap in the market for a device that can help people with allergies shop quickly and safely, so I decided to do some market research and see what was actually available. InFood is an app available on the Google Play Store. It allows users to scan a barcode, which in turn links to a database of products and their ingredients. If the product is not listed, then the user can add it by taking a picture of the ingredients. InFood then extracts the text and automatically adds them. This is the major issue. If the users don't check that the allergens were added correctly, then another individual could come along later and it would be correctly identified as safe. In the reviews, users also highlighted that the small database was an issue and the fact that they constantly had to be adding new items. This obviously also requires an internet connection. Allergy app works in a similar way by linking to a back-end database. It was designed to help contact allergic individuals whilst purchasing cosmetic products. The requirement by EU law means that products must have an international nomenclature of cosmetic ingredients names listed, which is a mixture of scientific, Latin, and English words. Many users obviously struggle to understand these, so this app shows all of the ingredients alongside the other names for them. The database is maintained by the partners of Allergy App. One of the well-known companies, for example, is L'Oreal. This app, however, is only available for Apple iPhone users and only works with skincare products. Food Allergy Scanner is another example, which is available on Google Play Store. It has similar issues as before, but another one that was mentioned in the reviews is that users are unable to add their own allergens. So after doing all of this research, I had a pretty good idea about what works well and what doesn't, so I went on to designing the product. My aim was to create a device that can assist users with allergens whilst shopping. To the best of my knowledge, all of the current solutions are currently mobile phone apps, which inadvertently cuts out some of the most vulnerable individuals. Many elderly people avoid technology both out of fear and out of confusion. They're also very likely to have eyesight problems, meaning that they may very well struggle to read the small product ingredients. So it was crucial that I created a physical device so that people didn't have to rely on having a smartphone. The idea is that it could be available at the door in supermarkets, so you can pick one up to help if you need one, similarly to grabbing a basket or a scan as you shop device. Allergy Safe consists of a Raspberry Pi 4, a touchscreen, a camera, two LEDs, and a speaker. It uses optical character recognition engine called Tesseract, which is maintained by Google, to extract the text and compare it to the user's list of allergens. Before I go into more detail, I'll play a short video to show an example of the device in action. One of the things I would really like to stress is the hands-free design. The device is there to aid users, not inhibit them. As part of my background research, I used the Scan as You Shop device in Tesco's to get some inspiration, and I was reminded how difficult it is to shop while holding one. I had a basket in one hand and that device in the other, so it was really quite challenging to actually pick up the items on the shelves. My device, Allergy Safe, perches on the side of a trolley or basket, keeping people's hands free available to shop. I followed a waterfall methodology for this project. This was because there were a lot of complex dependencies between the different layers of the device. For example, in order to program the user interface, the touchscreen had to be connected and functioning. One of the main advantages for following a waterfall methodology is the lengthy design stage, which allowed ample time to arrange and plan the intricate components working together. Just a quick overview of how the system actually works. Once a user is ready to start shopping, they can tap the screen to begin. After a few other pages, the screen will then show an empty list with the three options Add, Delete, and Start. When a user clicks Add, they will have the option to either select from a common list of allergens or type their own. Once the user is ready to begin scanning items, they can click Start. To save on battery life, the device only scans when the user clicks a button in the center of the screen. Upon clicking this button, a 3-second countdown will begin, giving the user time to pick up the product, steady their hand in front of the camera. The LEDs will flash on, a camera preview is shown, and the photo will be taken. Next, the system will extract the text and compare it to the user's list of allergens. The results are shown on screen. If it is safe, a high-pitched tone will sound and a large green tick is displayed. If it's unsafe, a low buzzing tone is sounded and a danger is shown on the screen. The system then stays in this loop until the user has finished shopping. To quit and stop using Allergy Safe, they can tap the X in the top left corner of the scanning screen, which then triggers a reset function, clearing all of the lists and resetting the device ready for the next user. I'll just play a short video that shows the full cycle of the screens and the device being used. So this first bit is showing clicking through the different pages and setting up your initial list. They can choose either to select one item or add multiple items at one time. This next video, I'll just briefly fast forward through this again. It's just showing exactly the same thing. Before, I'm adding wheat and milk into the list of allergens. What I'm picking up here is just a simple jar of olives, so it shouldn't contain either milk or wheat, so it should identify as safe after taking the image. The next thing I scan is some hot cross buns, which obviously do contain wheat. So this should trigger the danger screen and show that wheat was found as an ingredient. There you are. It's quite hard to read, but it does say contains wheat, do not consume. Now I'm scanning a packet of cheese, which contains milk. There we are, contains milk, do not consume. This also shows that to save battery life, the screen goes to sleep whenever it's not in use. The biggest decision that I made was switching to a Raspberry Pi instead of an Arduino. During the implementation stage, I realized that the Arduino microcontroller was not powerful enough to run the OCR software. Because this was such an important aspect of the project, I abandoned Arduino and switched to a Raspberry Pi, which I talk about in length in the report. Another crucial decision was when Another crucial decision was when to have the device scanning for allergens. I chose to have the user tap a button and start a 3-second timer, allowing them to position and steady their hand in front of the camera. I investigated having the device constantly scanning or including a motion sensor, but discounted both for the purpose of maintaining battery life. One key issue I was noticing when testing the device was that if the user's allergen and the text that was extracted did not match 100%, then the device would identify it as safe, which could obviously be quite dangerous. To combat this, I implemented a matching accuracy algorithm. This essentially works out the likelihood that the extracted word is the user's allergen based on criteria such as a similar number of letters or a sequence of letters matching in both words. Another important decision I made was how to let someone access the battery to charge the device. I opted for having the left side removable with screws, since this would help maintain security, since the shoppers and the users would need a screwdriver to be able to access the circuitry. This video just shows me installing the circuitry inside the casing. As you can see, there's a little hole in that platform to allow the camera ribbon to come up safely to avoid damaging it when the Raspberry Pi sits on top of that platform. At the front there's the two LED holes and the camera. This is with everything inside the casing. You can see the Raspberry Pi and the screen attached together at the top that are sitting on that platform I mentioned. The left side that's removable has a matching platform, so it sits comfortably on there, keeping the middle section available for wind flow and making sure it doesn't get too hot. On the right hand side there, you can see the LEDs and camera being held in place by some masking tape, and that big black box in the center there is the power. A survey showed that users thought that it was easy to use, a good design, and that they liked the colour scheme. However, they did mention that it was quite large, so in future I would investigate making this smaller and less bulky. As part of this study, I also recorded the time that it takes 3 human participants to read the product ingredients and decide if it was safe, and then compared this to the allergy safe device and how quickly it would do it. As you can see in the table, it was significantly faster than humans most of the time. I'll also highlight that all of these participants do have experience in shopping for someone with allergies, so it cannot be generalized to the wider public. It could be slower, it could be faster, but due to COVID-19, I was unable to get more participants. Some potential future areas of improvement involve showing other safe alternatives available in the store if a product is unsafe. However, this would require adding an additional database as a backend and identifying other names for allergens. For example, if someone enters dairy, the device should recognize milk. That's everything I wanted to cover. Thank you for listening.